Alright, let's continue with question 3 from 2024, paper 2. Okay, 3A. So this question I think is on ideal gas equation. Okay, it's quite rare that we have so many questions on ideal gas, but let's get down to it. So you have ABC, basically carbon, hydrogen, and oxygen atoms, organic compounds. Each compound contains one hydroxy functional group. So basically have a OH. Okay, so when a sample, okay, let's just highlight all the data we are given. We are given the mass, we're given the volume in cm cube, we're given the pressure, we're given temperature in degrees Celsius. So we actually need to convert all of these variables to SI unit. So to convert to meter cube. Alright, so this one you need to multiply by 10 to the power of minus 6. Then for degrees Celsius, you need to add 273 to get to kelvins. Alright. Okay, so all of this you just sub into the ideal gas equation, which is PV equals to nRT. Since we are given mass, right? So it will be mass over molar mass times RT. Okay, so we are given mass, we are given volume, we are given temperature, okay, so we just substitute all this in. Pressure will be as at the 101325 Pascal. Then volume will be, where is your volume? 250 times 10 to the power minus 6. Mass will be 0.5 grams. This is our unknown. R is 8.31. T is 93 plus 273. So you just need to substitute all these values in, right? Then you will get a big M molar mass of 60.0. Okay, which also tells you the MR of A is 60.0. Okay, so for 60.0, if the formula is, it is a hydroxy formula group, functional group, so you have HCH2OH. Okay, so just let it be equals to 60 and basically find your N. So in this case, your N is equals to 3. Molecular formula is C3H8O. Okay, so that is your answer over here. Now, let's look on at the second part. Part B. Both B and C have molecular formula of 74, which is a difference of 14, right? This 14 will correspond to a unit of CH2. Okay, just a one more to the carbon chain. Table 3.1 shows where separate samples of B and C are added. So you have an oxidizing agent dichromate. B will get oxidized, C will have no change. Okay, so single organic product that reacts. Okay, so you'll get a ketone because it reacts with 2,4-DMPH, but yet it does not react with phthalate. So no aldehyde, but it's a carbonyl, so must be a ketone. Okay, so this is likely, B is likely a secondary alcohol. C cannot be oxidized, most likely is a tertiary alcohol. Okay, then we also told that B has a special structure. So B has this structure. Okay, so you just need to include this structure for B, right? Which tells you the OH is on the second carbon. So draw 1, 2, 3, 4. Put the OH on the second carbon. Voila, that's your B. Okay, for C, I think for 4 carbons, right, there's only one way to draw it. It's tertiary alcohol. Okay, one secondary, one tertiary, and there is the special structure for B. Write the half equation for the species that is reduced when B is heated with dichromate. So it's the dichromate that is being reduced to chromium ion. So just pick out the half equation from your data booklet, the CR2072 minus plus 14H plus 6 electrons give you 2 chromium 3 plus 7H2O. This is directly lifted from your data booklet, so just go and look at it. Name the pale yellow CHI3 lah. We have done this so much until it's like yeah. But don't forget to name it. Not just state, you have to name it. This is triiodomethane. Okay, in order to earn that 1 mark. Explain why chromium ions are colored, right? This is a very standard explanation for why transition metal ions are colored. Okay, so you basically talk about complexes. For complexes formed with chromium ions, in the presence of ligands, okay, your partially filled 3D orbitals split into 2 groups of non-degenerate 3D orbitals with a energy gap. Okay, so then when exposed to visible light, the electron from lower energy absorbs a particular wavelength of light and promotes to higher energy level. Okay, so this is DD transition. Okay, the last point, complementary color is complementary color of the wavelength absorbed is observed as color of complex. Okay, so in total, right, there is like 3 main points. First point is your d orbital splitting, and then second point is your dd transition. Last point, the color that is not absorbed, right, the complementary colors are shown as the color of the complex. So 3 main points. Okay, DD transition, and this one is d orbital splitting. Okay, so a very standard 3-point answer for 3-mark question. So this question comes out almost every year. Okay, make sure that you guys know how to answer this question.